Welcome to the Lava Academy podcast, your monthly dive into the world of volcanoes, lava, and the forces that shape our planet. We're a team of lava enthusiasts based in Reykjavík, Iceland, part of the crew behind Lava Show, the world's first live lava show, where we remelt real lava and pour it out in front of a live audience. But this podcast is where we go deeper into the science, the stories, and the people behind the eruptions. Each month, we'll bring you the latest volcano news, along with conversations with a range of guests, from leading geologists and volcanologists to locals who've witnessed eruptions up close. We'll cover everything from the science of how volcanoes work and the tectonic forces shaping Iceland, to the ongoing activity on the Reykjanes Peninsula, historic eruptions, and the ways in which volcanic events impact people and communities. Whether you're a curious listener, a science enthusiast, or someone who just thinks lava is cool, and it is, then this is the podcast for you. Welcome back to the Lava Academy podcast. I'm your host, Ian MacKinnon, a former primary school teacher from Scotland, now living in Reykjavík and playing with lava for a living. Yes, really. And I'm joined by my co-host, and we have a slightly different co-host this month. Was Hellisheiði, but stepping into Jón's seat is Ragnhildur Ágústsdóttir.
Hello.
Hello. Yes, we met you last time as a guest, and now you're in the chair.
Yeah,
How does it
I
feel?
must have been so good that, I just had to step in.
We fired Jón.
No, absolutely not. Jón, I think, had his very quirky, interesting touch to it, and I just hope that I will be able to step into his shoes.
I am sure you will have no problems in doing that. So although the co-host is slightly different, one thing is not different, and that is that we've got a fantastic interview for you this month. So let's go right ahead to that interview right now. Okay, so we're joined today by Kári Valgeirsson, who is the science communicator from the On-Power Geothermal Exhibition at Hellisheiði. Welcome, Kári.
Well, thank you so much for having me. Thank you.
So, can you tell us just a little bit about yourself? Like, what is your role at the Geothermal Exhibition?
Yeah, my role at the Geothermal Exhibition is science communicator, where I am taking groups and or people and giving them a tour about how we produce energy at the Hellisheiði Geothermal Power Plant. And myself, I am, of course, Icelandic, and I'm a geologist, studied here in the University of Iceland. Mm-hmm. And now I'm doing my master's in Reykjavík University.
Excellent.
We love geologists.
Yeah.
Yeah. I'm just super curious, in terms of what geothermal energy is. Can you explain that to us and our listeners just a little bit better?
Yeah. I mean, if we take the word apart, for example, then geo, the earth, and thermal, heat, kind of. So, I mean, this is just heat within the earth itself. So that's like the purest definition on that. Mm-hmm. And for example, if we drill into the earth, then we mostly get some kind of heat. And where you're located maybe on the earth depends on how hot it gets by depth, kind of. Yeah.
Okay. So how is this connected to volcanoes?
Yeah, how does this connect to volcanoes? Yeah, that's a good question. I mean, the thing is, for example, here in Iceland, we have a lot of volcanoes. We have a bunch of them, and some of them do have some geothermal activity, especially on the surface. Mm-hmm. And that is because volcanoes, if we take apart the earth and just drill directly into the earth and just way down, they will have somewhere a magma chamber, of course. And this magma chamber is just molten lava down below. And that has a lot of heat within it. And so this heat, sometimes we have like intrusions of the lava itself coming up, not maybe to the surface, but near the surface. And so more of that heat gets transferred to the rock surrounding the intrusion itself. And there we get this like hot geothermal system where the heat itself comes up from the magma chamber itself.
Yeah. And Iceland's got a pretty long history of making use of this. When did this begin? When did they first start using geothermal energy here?
That's the thing. I mean, all of the bigger things in Iceland, for example, Reykjavík, the capital, is called Reykjavík, or if we take the word apart over there, that's Smoky Bay. Reykja, Smoke, Vík Bay. So I mean, if we take that, then the settlers that came here, they were used to geothermal right at the beginning. And then we have, for example, Snorralaug, which is in English Snorri's pool, and that was established in 11 to 1200 or something like that. So Snorri Sturluson had a hot tub in the year 1200. I don't have a hot tub right now, no.
He was pretty cool.
Yeah, exactly, yeah. So I mean, in terms of these low temperature usage or heating and stuff like that, we have used that for centuries and stuff like that. But in terms of electricity production, that was mainly established in the late 1960s. Yeah.
Okay, so were there, and you mentioned the late 1960s, were there specific things that were happening at different points in history that were maybe forcing people to use the geothermal stuff more than the kind of, if you like, traditional?
If we go back to maybe the early 1900s, then the district heating system was expanding, especially in Reykjavík during that time. But by 1904, maybe not in Iceland, in Italy, for example, there they started using geothermal to produce electricity. So the idea was put forward down there, but we were not maybe doing it over here. We were mainly focused on district heating. But then by having the knowledge that this can be done, then were plans to do it kind of more in Iceland. And then by 1960s, 1970s, we had, for example, the oil crisis. And from there, we were importing most of our energy in the form of oil and coal and stuff like that. But since energy prices were skyrocketing, that was not very good for the Icelandic population. So we would need to, use more of the energy that is available within the island itself. And that is geothermal and in part hydro also. So external factors were kind of contributing to that. Yeah.
Okay. Actually, I find that quite interesting because I'm born in the 1980s. And if this is happening, but I mean, if this is only happening late 1960s, late 1970s, it must have happened really fast because I don't remember anything else apart from geothermal energy in Iceland. That's anything other than that is before my time.
Exactly.
So it must have just happened really fast.
It did happen really fast. And if we take, for example, the energy part itself, not electricity, what we call primary energy consumption, meaning all energy on the island itself. That's transportation, that is electricity, heating and stuff like that. By the middle 1970s or something like that, Iceland was roughly 50% renewable or geothermal in that regard.
Okay.
Yeah.
50%?
Exactly,
That's crazy.
Yeah, that is crazy. Most of that is, of course, the heating part itself. Yeah. But still, by 1970s, 50%.
I mean,
so how much is it now?
Coming from a UK perspective, I mean, that's just bewildering.
Exactly.
Because although we were maybe at that point, we were beginning to use maybe more kind of hydroelectric and stuff at that point. It certainly wasn't anywhere close to that kind of uptake of renewables. That's crazy.
So what is it now? Do we know?
It's roughly 86% renewable for primary energy production or consumption on the island. And geothermal is roughly 65% of that. Yeah.
But I mean, Iceland is pretty uniquely suited for geothermal energy, isn't it?
Yeah.
Can you explain, what is it that really contributes to that?
Yeah, like we were talking about before with the volcanic systems, we have a lot of them on the island itself. And we also have the geology favors kind of these geothermal systems in that way that they are easily accessible. These are mostly Iceland is mainly composed of these basaltic formations, and a lot of the time basalt has good porosity and good permeability also. And porosity and permeability, the porosity itself is the percent of holes within like some defined area, and the permeability is how easily water can flow through, for example, these rock formations themselves.
Okay.
And Iceland favors these two geological factors, especially very good. And another thing is that we have a lot of rain on the island.
And that helps.
Yeah, that helps. Yeah. I mean, precipitation, also glacial melt and stuff like that, favors that, for example, the water seeps into the bedrock and then, like we were talking about before, goes nearby the heat source or this magma chamber down below. Then this water gets heated up, and then that kind of what we call transfers into the geothermal fluid, we call it.
Okay, so hold on. Whoa.
Yeah.
Press pause here for just a second here.
Yeah.
So, no expert on geothermal systems or anything like that.
Yeah.
But you're talking about the porosity of the rock and, how well water kind of transfers.
Yeah.
Part of my kind of understanding of geothermal is you just drill a big hole, run pipes down it, and it just gets heated up there. Why is the porosity of the rock kind of...
The porosity is, for example, how much water one of these areas can hold inside of it. So that is not how easily water can travel, that's permeability, but this is how much water can be stored in the geothermal reservoir itself. I mean...
So it's not simple. It's not as simple as you just run a pipe down and it just heats up through the pipe.
No,
it's being held in a reservoir under the surface and then coming back up.
Yeah, exactly. Yeah, and what is maybe the like some people confuse this when we call it the geothermal reservoir. It is not just like a big water tank kind of that is sitting below the surface. These are like veins of geothermal fluid going down. Sometimes we can have water pockets and stuff like that. So it's not just like a big pool of
It's more
water.
like a sponge under the surface.
Yeah,
right?
exactly. Yeah, sponge is a very good analogy for that. Yeah.
I mean, I feel as a local, I feel like I should know more about the details about this, but I mean, I'm already learning quite a bit here. So thank you for that.
No problem.
So around the country, I mean, when you drive around Iceland, you see like you can see steam rising up all over the place.
Yeah.
Are there specific places that are more kind of rich in geothermal resources than other places?
Yeah. For example, when you are looking for a what we call a high temperature geothermal system, where, for example, that is within a volcanic system, you want to first look onto the surface, you want to see the regional geology, and one of that can be what are the geothermal manifestations on the surface. Like, for example, the most famous one is probably geyser in Iceland. Yeah,
right.
Geyser, yeah. And that is when you have, for example, geysers and geyser. I mean, the word
the name,
geyser, the word geyser comes from the Icelandic word geyser, meaning just water erupting to the surface or something like that. So, I mean, when you have manifestations like that, geothermal manifestations, you probably have some fracture in the bedrock where water can also easily flow upwards. And why it flows upwards is because of the both pressure difference between the water column itself and the heat within the earth. So you have a lot of heat down there, but it's under so much pressure that when it comes to these fractures and stuff like that, it kind of shoots up to the surface. Yeah.
So where there are geysers, you're more likely to find, spots where you can actually activate the energy within.
Exactly. Yeah.
But these geysers,
Yes.
geysers, they're actually they're not common. They're quite rare, particularly the true kind, the one that you think of when you think of like, Old Faithful at Yellowstone or Geyser. Why does Iceland have them more so than other places? Do you need very specific things going on down there in the plumbing to actually get it to happen?
Yeah. Like this is also a good word that you use, the plumbing.
So good with words.
Yeah,
words,
exactly. Yeah, no, people sometimes call it like the plumbing system, where the water is traveling through these channels below the surface. I mean, we were talking about porosity and then permeability. Sometimes these factors are also why Iceland has a lot of these geothermal manifestations. And Iceland is very favorable for that. And then, for example, Yellowstone area. But other volcanic systems don't necessarily need to have these geothermal manifestations. I mean, we were talking about, we have a lot of these volcanic systems, but most of the time we only look at, for example, Geysir or Seltún in the southwest over here. And Hveradalir, where Hellisheiði Power Plant is located at also. But then you look at, for example, where Svartsengi Geothermal Power Plant is located in Iceland, and where the Blue Lagoon also is located, if you want to get like specific where it is located. And there we kind of didn't have any geothermal manifestations beforehand. But people were like, yes, this is a volcanic system, so maybe if we drill into that, we also can get some geothermal usage from this volcanic system. And of course they did do that, because now we have Svartsengi.
Right. And it's become, I think, way more famous after all the eruptions that have been taking place on the Reykjavík Peninsula. So.
Yeah, exactly.
So these are basically all these kind of surface things. They're kind of indicators that you could use as just to kind of clue you in as to where might be a good spot.
Exactly.
But it doesn't necessarily follow that.
No,
that's the case.
Exactly, yeah. It doesn't necessarily need to follow. And people are also quite wary of utilizing the areas where you have these geothermal manifestations. I mean, Geysir in Iceland and Seltún or Krýsuvík geothermal system, those are protected. You can't build geothermal power plants or stuff like that from there, maybe in the future, because Krýsuvík now has some experimental drilling. But Geysir, for example, will probably never have any kind of production over there, because that is, you have to kind of have like the difference between, yes, is this a good place for power production, or will we get more money for example, tourism or something like that?
I mean, it's quite special to witness this. It is quite
special, yeah, exactly. So you have to know all of these things, and you can't just build a power plant wherever you like, but you could theoretically, harness the power within Geysir, but you have to also think of the social factors.
Yeah, so these kind of areas, particularly like areas like Geysir, they require some protection.
Yeah. Kind of. Yeah. I mean, it is on a private land, so theoretically, the owners of Geysir could.
They could if they wanted to.
Yeah, if they wanted to, but I mean, they're probably not going to do it.
Yeah, so you're basically saying you're not just going to slap up a geothermal plant pretty much anywhere. There's going to be some.
Yeah.
There's got to be some thought going into the impact, not just on the area, but also on things like tourism.
Yeah, exactly. I mean, Iceland has what we call rammaáætlun, or the master plan, where all the master plan
sounds very sinister.
Yeah, exactly. Yeah, but the master plan is where power companies can come to the table and say, like, "Hey,
with
we want to build."
robes.
Yeah.
Sorry.
No, of course, no problem. Where power companies can come to the table and say, hey, we want to build some kind of power infrastructure over here.
Yeah.
And then there are some specialists from the field that are saying like, hey, okay, we will check out if there are any environmental concerns and stuff like that. But then the government of Iceland has the final say. And the final say is that it is yes, no or on hold.
Okay.
Or yes, no can most often mean like protected.
And I mean, as a local, I've heard all of these conversations in the news and all.
Yep.
It's not necessarily always to do with geothermal power plants.
No.
Sometimes it's more with, where you have to build a dam and
the hydroelectric stuff.
Yes,
Yeah,
exactly. Yeah. All power generation, whether that is geothermal, hydro, or even wind.
I mean,
exactly.
again, coming from a UK perspective, this is a big deal with us just now because
Mm-hmm.
back on the island, and I'm from the Isle of Lewis, there are plans at the moment. There's a lot of
debate.
Yeah, exactly.
debate
Yeah.
and some very angry people.
Yeah.
Based on what could be happening as a result
Exactly.
of that.
Yeah. I mean, the discourse in Iceland has been that, I don't remember if it was master plan number 4 or 5, but there were a lot of private companies entering the energy market over there with their wind power projects, and most of those were put on hold by the government itself.
It seems to me, just as an observer of what's going on here, it seems to me that the geothermal stuff, although, it clearly does have a visual impact, where you have a plant. I mean, that's going to be the case regardless.
Yeah.
But it seems to me that the visual impact of one power plant as opposed to an enormous wind farm development it's actually significantly smaller impact than that.
Yeah, I mean, yes, you can think of that. For example, with Hellisheiði Geothermal Power Plant, it is located near Highway 1 or Þjóðvegur 8 in Iceland. And from there, people can always see it. If you're driving to Hveragerði from Reykjavík, the nearest town, you will always see it, but people kind of don't mind it because before there was kind of nothing over there, not in this particular area. But yes, you see some like steam coming from the cooling towers of the geothermal power plant, and you will see some pipelines in the area itself. But I mean, if it doesn't impact too much the residents of the nearby towns, I mean, I think most people are just okay with it.
And I mean, I think also, seeing something can also attract attention. And I mean, in your case, you have like set up this show where you're actually welcoming guests and educating them about geothermal energy, which I think is really cool. I mean, we're all about, education and edutainment, as we talk about it here. And I mean, we're pointing people in your direction all the time.
Exactly. Yeah. And I mean, people are coming from just Highway 1. They're going to the nearest town and they're going to maybe eat or something. But then they see the steam from the cooling towers and say like, hey, is there something? Is there something we can check out? And a lot of people are saying like, we have like statistics on like how did you find out about the exhibition? And a lot of the time people are saying like, oh yeah, we saw the steam. Yeah. So,
and we just decided to drive by and check it out.
Yeah, exactly.
Oh, really?
Yeah.
Okay. Yeah.
That's crazy.
No, but I mean, I think, it's the same. I mean, of course, like with wind farms and stuff, like they take up more space, but some people are fascinated with them. The same with dams. I mean, dams, like the Hoover Dam is really famous in the States as an example. So
exactly.
It can have very negative impacts, and then it can also be an attraction in itself.
Yeah.
Okay, so going back to kind of geothermal, we've kind of had a little kind of overview, like a very broad overview of what goes on. But can you actually now can you step us through the journey of that geothermal energy from the point at which the power plant is dealing with it to the point where it actually gets into your home?
Yeah, exactly. For in the case of Hellisheiði Power Plant, we are producing two things. We are producing both electricity and then we are producing hot water for the residents of the capital area. And the first thing that you do is that you, like we were talking about before, you drill into the earth and try to hit these geothermal veins or into these geothermal reservoir And
And is that just like a hit or miss thing? Is that the case? They just have to
No,
repeatedly drill new ones to say, oh, there's one. You know?
no, I mean, you kind of don't want to drill anywhere because drilling can be quite expensive, especially in these high temperature fields. So you have to do some, for example, geophysical measurements beforehand. You can do some gravity measurements, resistivity measurements, check out the geochemistry, check out the weather data. If it is raining, you can check out the porosity and permeability. And if all of that indicates a geothermal reservoir, then you can drill first an exploration well, just to see like the geology also down there, because alteration minerals that form just at specific temperatures can also say like, hey, this temperature is down here.
Okay.
And we can check that out. And then after that, you can have some production borehole. And the production borehole, for example, in Hellisheiði goes to roughly 2 kilometer depth. And you get a mixture of both geothermal fluid and steam coming up in the borehole together. And then geothermal power plants have what we call a separator, where we separate the steam from the geothermal fluid. Then the steam is used to drive the turbines to produce the electricity itself. And then the geothermal fluid is used for a heat exchanger, where we heat up fresh groundwater. Then this hot groundwater is sent to the capital area.
Yeah. So it's not the stuff that was down under the surface that's going piped out. It's being used to heat water at the surface, and that's then being pumped.
Exactly, yeah.
So what is that geothermal fluid? I mean, what does that consist of?
Yeah. This geothermal fluid is mostly water, but with a lot of dissolved minerals inside of it, and mainly that is silica.
And is that just kind of precipitating within that water because of the heat and pressure?
Yeah, exactly. Yeah, when you have these high temperature geothermal systems, a lot more of these minerals will precipitate out from the host bedrock itself into the geothermal fluid or the water. But in, for example, these low temperature geothermal systems where you don't need to drill these deep holes, then not a lot of the mineral content is, for example, the same with the high temperature ones. So you can use that directly for house heating or district heating.
Okay.
That's the low...
That's the low temperature which you can use directly for district heating.
Right.
Okay.
But for the high temperature ones, because of the high concentrations of these minerals, then you use a heat exchanger and then send that to the district heating.
We hear that a lot from people who either, move to Iceland or come visit Iceland, that, they can smell the hot water.
Yeah.
Like they take a shower and they're like, what's this weird smell?
Yeah.
So
what is that weird smell?
What is that?
Yeah.
Why is that?
The weird smell comes from the sulfur content in the geothermal fluid itself.
Right.
And for example, here in the capital, we use low temperature geothermal systems and high or like the heated up fresh water itself. But the reason is also that the heated up fresh water, especially at Hellisheiði Power Plant, we intentionally put some sulfur inside of it.
Okay, why?
Why we do that is because when we take the water out and we heat it up, a lot of the oxygen in the water itself, like we have a lot of oxygen in this hot water, and so the sulfur will bind with the oxygen itself to form sulfuric acid, and that helps with the corrosion of the pipelines.
I was going to say,
themselves.
because oxygen plus pipe work is not a good combination.
Exactly, yeah. So you want to get rid of that, and we do that in this sulfuric way.
Okay.
So that's basically latching onto the oxygen, taking that out of the equation and protecting the pipework in the city.
Exactly, yeah.
Interesting.
So
and
that is why we
with
have
the
that
subsequent
eggy,
smell.
Yes,
exactly.
Hence the eggy smell.
Of course, yeah.
It's...
and I mean, so you can drink the hot water, but I would never recommend it because it doesn't taste very good.
No, it does not.
No, but you can drink it, if you want.
Is there like a lifespan for these power? I mean, could they just run indefinitely, or is there a point at which you kind of run out?
Yeah, that's the thing. Also, I have been talking with a lot of professionals from the field itself, and some of these professionals they are not like, they have different opinions. Some say that if you have a high temperature geothermal system, then you can exploit that too much and you just drain it out in maybe 30 or 40 years or something like that. But I never want to say some years because every geothermal system is different.
Yeah.
It's just like the people. Everyone is different in that way. These low temperature zones, usually you can use them quite a lot, for a lot longer time.
Okay.
But the high temperature ones, I mean, you can have. Now I'm gonna say something. Yes. For
Here
our,
it comes, folks.
Okay, prepare.
No, I mean for our American friends that are listening to this, yes, the United States has the largest geothermal power plant in the entire world that produces electricity. That's called the Geyser Complex, located in Northern California, United States. What they did over there, like for example what we did here in Iceland, is that this was put forward in the beginning of this oil crisis, in 1970s or something like that. What they did over there, instead of what they should have done, is that they just had massive amount of infrastructure put into place in a short amount of period. So they had, I don't know if you know this, but Hellisheiði Geothermal Power Plant is 303 megawatts of electricity. There they installed 3 gigawatts of electricity, 10 times as much for this one geothermal system.
Wow, that is a lot.
Sorry,
That
I'm
is
just
a
having.
lot, yeah.
It goes through my head just 1.21 gigawatts.
Exactly, yeah. Back to the yeah. No, I mean, what they did over there was they installed this massive infrastructure over there, and they kind of drained the geothermal system too much in a short amount of time. So now they're down to 1.2 gigawatts of electricity.
Okay.
And they had to even resort to using treated wastewater to re-inject into the system to get some kind of water content into the system.
Wow.
So they basically tapped out.
Yes, I mean they tapped out.
It dry.
Yeah, I mean they tapped out in terms of the liquid content, yes, but in terms of the heat content, maybe not.
Yeah.
Because I mean there's maybe less precipitation in Northern California than, for example, here in Iceland, and so maybe they drained the liquid content, but the heat is probably still over there.
So one needs to be careful
Yes.
when developing these geothermal.
Exactly. Yeah.
Energy
Yeah.
plants.
You can install a lot of capacity in the beginning, but then you would need to massively reduce your.
See, I never thought about that. I never really thought that there was like a sustainability
No, I didn't think
problem
about
with this. I
Yeah.
thought it was like, well, you know, it's there. It's
Yeah.
just
It's nature.
It's just hot.
Yeah.
You just keep on going. But
Exactly.
no.
But this is also the thing. This is why I was saying that these professors and professionals have been debating about the renewability part, is because a lot of these geothermal systems have been utilized for a lot longer time and are still producing the same amount of electricity from their beginnings. So, I mean, how you do it also defines on the system itself. So each system is different, and you can probably have a shorter amount in some of them and just, I'm not going to say endless, but still a lot longer time in other ones.
I mean, this story sort of leads me to thinking and wanted to ask you something really basic. I mean, is it possible to simply drill too far? Like,
I mean, drill too far, maybe not, but I mean, you can drill into the magma chamber itself.
One would think that might be a bad idea.
That is a bad idea. We did do that here in Iceland. Yeah, we did do that here in Iceland in 2009, if I remember correctly, in what you call the Icelandic Deep Drilling Project.
up north?
Yes,
By
exactly.
Krafla?
Yeah,
Yeah.
exactly. Yeah.
Okay, and what happened?
What happened is that the Iceland...
The island exploded.
Yes, yeah, exactly. No, I mean, the IDDP, Iceland Deep Drilling Project, was established because people wanted to drill longer than the conventional drilling was happening, which was roughly 2 kilometer depth, 1.2 miles depth. They wanted to go to roughly 4 kilometer depth or something like that. What they didn't anticipate over there was that they drilled into a magma intrusion at roughly 2.1 kilometer depth. Yeah. And what happened when they drilled into that magma down there was that, I mean, a lot of corrosive material, and probably the smallest eruption ever to happened over there.
Okay.
That's what they called it. But still nothing.
So what does that mean? The smallest eruption?
Yeah, I mean, there was...
Like a minute?
Yeah, I mean, yeah. It was kind of small amounts of some magma that came to the surface, but not a lot. I mean, if I remember correctly, this is going by memory right now. But they closed out the well, and they could do that over there. But the idea continued on, the Iceland deep drilling project, and what they did in Reykjanes.
So hang on.
Yeah,
Which
yeah.
is pressing
Okay,
pause.
yeah.
So rather than just saying, whoops,
Yeah.
let's not do that again,
Yeah.
they were like, maybe we could do this
Yeah.
again, but actually make it work.
Exactly, yeah. And the
So
Iceland...
they're still at it?
They're still at it, yeah. And there is now a deviation program going on in Krafla, like I was talking about. They drilled the IDDP-2 well in Reykjanes, but what they are going to do in Krafla, they call it KMT, Krafla Magma Testbed, where they are going to harness the power of the magma chamber itself.
Okay.
So this sounds like a magnitude jump of like going from a coal-fired power station to a nuclear power station, but with geothermal.
Exactly. Yeah. This is what you call the supercritical conditions, where water is at just like any kind of phase, kind of down there at like roughly 400 degrees Celsius and 300 bar pressure, which is 3 times the atmospheric pressure right now. And 300 times, sorry. And so what you are trying to do over there is that you are trying to harness as much energy in the water itself, or the geothermal fluid. And the reason being is that when you have, for example, a regular geothermal well, you can get like 3 to 5 megawatts per well of electricity. The theoretical thing that they were doing over there was to do like roughly 50 megawatts per well. So 10 to 15 times as much energy per well.
Wow.
Yeah. That's a lot also, yeah.
Okay.
So you can see why they'd want to do it.
Yeah, exactly. Yeah, maybe another thing that we can mention is that maybe one of the bad things about geothermal power is that it does take a lot of land area.
Yeah.
So a good thing to do in these supercritical conditions is that you don't need to have this big land area, because you don't need to have a lot of these boreholes and stuff like that. Then you can just have one well supplying enough energy for the geothermal power plant instead of these 10, like I said before. Yeah.
But if this big project up north becomes successful, if they actually succeed, what does that mean for Iceland, or even in a broader sense?
It means that we will probably try to do it in a lot of other places, but each geothermal system, like we were talking about before, is different and comes with different corrosive properties. And so if you drilled, for example, here in the south, that's maybe different than, for example, there in the north. In a broader sense, for the whole world, is that it will probably be more accessible to other countries utilizing geothermal energy, because then it is established that you can go to these depths to use.
Because actually, that actually feeds into something that I was about to ask you, which is that, is this geothermal thing, is it an exportable model to other places? Because if the kind of geology that you're talking about for the kind of normal kind of geothermal thing, if that doesn't exist in some places, that might not work. But you're saying with this deep drilling stuff, it could work. Potentially, yeah.
Interesting.
Yeah, and I mean, if we go, for example, over countries that are producing electricity through geothermal, then, like I was talking about before, the United States is doing that. There are even some countries inside Europe, Italy, Turkey, a small one in Germany, Iceland, of course, and stuff like that. Africa, Kenya, we have Ethiopia, Djibouti, even if I remember correctly. And then we go to Asia. Japan has a lot of these geothermal power plants. And then New Zealand also has, Indonesia, Philippines and stuff like that.
I mean, there's lots of places with volcanic activity. So
Exactly. Yes, exactly.
I mean, the Ring of Fire, basically
yeah.
surrounding the Pacific Ocean is like home to 75% of all the volcanoes in the world.
Exactly. Yeah. So theoretically, you could do this in a lot of other places that are maybe... Iceland is mainly popular because we have this high amount of geothermal energy produced for the energy on the island itself, kind of.
Right.
But in other places where you have, for example, more population and an even sparser population, stuff like that, then geothermal energy is probably a part of something over there, but it's such a small part that most people don't know about it. Yeah.
Okay. Yeah. Interesting. I mean, I find, because for us, it's so normal. Like us who are born and raised here in Iceland, this is just the way.
Yeah, exactly.
Right? And then, it's like once you grow up, you realize, oh, this is not normal. And I remember I was doing some videos not long ago about the eruptions on the Reykjanes Peninsula, and I mentioned the power plant. I failed to mention that it's a geothermal power plant. Yeah. And like the onslaught of comments, like, oh my God, is this nuclear power plant about to explode? And I was like, wait, no.
Whoa.
Exactly.
Yeah, exactly. So, I mean, most people are maybe not affiliated with geothermal power. So this is also really good that we have the Geothermal Exhibition open, so people can say like, hey, what is this? What is this place? What do you produce?
So, like, in that role then, as this kind of science communicator that you are, you must come across a lot of misconceptions that people have about geothermal.
Yeah.
So can you tell us the kind of things that people just don't quite get?
Maybe less with geothermal because we also talk a lot about the geology of the island and stuff like that. So I mean, maybe that is also some misconception about that. Is that I've had maybe a lot of questions from what's a lot of questions that I get now I can't remember.
Put on the spot.
Yeah,
and then
exactly.
Of course
When you're on the spot, No, those are mainly just about the production of the power plant and stuff, like a lot of the pipelines that we have in the production part of the power plant are going in like a zigzag motion, and that's to do with the thermal expansion of the pipeline of the metals inside the pipeline itself. And I don't know, people, because this is maybe the first time checking out a geothermal power plant, then people are maybe not. They're just soaking in information. There's maybe not a lot of misinformation, but the misinformation can be that they are missing the information in that way that when I tell people the States has the largest geothermal power plant in the world, they're like, oh, yeah, I don't know, yeah.
But I mean, I assume you get a lot of school groups. We get a lot of school groups here. And from our experience at Lava Show is that, very often it's the kids that ask the craziest, most interesting questions because they're so unafraid to just,
exactly
shout it out there.
Yeah.
So is that the same with you? Do you get like fun questions from kids?
Yeah. I mean, one time we got a question because they probably had before done something with like the history of Iceland and stuff like that we were under Danish rule. And one question, maybe not related to energy, but I got the question of, is Iceland now under the English queen? Or that was when the queen was alive. And I was like, no, we are still over here. We're just independent Iceland. And then, maybe the question I get most often asked is that, can you export the energy?
Right.
Like the energy, just the raw electricity. And I'm like, theoretically, yes, you can have like a big power cable going to, and because most of the time these are like kids from the UK, I say like, oh yeah, we can connect it to the UK. Theoretically, yes, but then our energy prices would also go up in terms of that.
But imagine that this question is coming from kids, because I mean they've been having an energy crisis over there, and it seems that the news of that probably are circling in the media is even like drilling down into the minds and brains of the kiddos.
That's one thing actually. When I tell people, because I mean Iceland is, let's face it, it's famously expensive.
Yeah,
to be here.
It is. Yeah,
one thing, or at least two things rather, which are cheap: hot water, electricity.
Exactly.
Yeah.
To the point where, and this blew my mind when I came here first.
I know what you're gonna say.
Where I'm
embarrassed already.
No. Well, yeah. If you go to any Icelandic person's home, in the dead of winter, minus 15 degrees outside, freezing cold, you rock up at somebody's house, I guarantee you, every window in that house is going to be open.
Oh yeah. You need to have
We're nothing.
You need to have some kind of convection inside the home. So I mean, convection of cold water and hot and stuff like that. So
but I just had visions of my father running around, kind of shutting it around. Who do you think's paying for all this?
Exactly.
And the other thing, kind of tied to that, was standing on my father-in-law's driveway in that dead of winter, freezing cold outside, and noticing an unusual pattern in the frost at my feet, and thinking, what is this weird zigzag pattern on the driveway? And then it kind of hit me, oh my word, they have underfloor heating on the driveway.
Yeah, outside.
Yeah, outside. Yeah, exactly. Yeah.
I mean, you would never get that back.
Yeah.
Well,
never.
Here we have the privilege of cheap and abundance of hot water.
Yeah.
And cheap electricity. And I think we do not realize, unless you move to a different country, this is something that you're like, it's like you're completely blind to this privilege.
Exactly. Yeah. Maybe one thing that...
spend one winter in the UK paying for the heating there, and that will wake you up to it pretty quickly.
Exactly. No, I mean, the only thing is that there was like a year or two ago or something like that when we... it was particularly harsh winter, so it was a lot of frost outside. And the thing that the distribution company inside the capital did to kind of preserve the geothermal or the heating was to close down the public swimming pools. Yes. And people were outraged in that. Yeah, exactly. Yeah.
What? We can't have our hot tubs and outdoor warm swimming pools?
Exactly.
But it's our civil right.
Yeah. So imagine that. Imagine how good we have it if we are outraged by our public swimming pools being closed. Yeah.
But I think that's also one of the things that most people who are not born and raised in Iceland don't realize, that we use the geothermal heated water to heat our homes. We don't use other means to heat our homes.
Yeah, you don't have a water heater. You don't like a gas boiler or something.
And it's not like something per building. It's like sort of a collective open system that everybody uses.
Yeah. So I mean, and each municipality kind of has their own district heating system. So we have a lot of smaller like towns all across the entire island, and most of them have their own district heating system with their own geothermal boreholes and stuff.
Well, we've been going for a while now. We really basically need to wrap this up.
Very good.
So
it's fun.
Yeah, it has been fun. This has been great. Just going back to your role, people visiting. Anybody, say for example, anyone who's listening to this goes to the geothermal plant at Hellisheiði, and kind of, what's the one thing that you would hope that they would walk away understanding about geothermal energy?
Understanding geothermal energy for other people that are coming to the exhibition, I want people to understand that this can be done in a lot of other places. It just depends on how deep you have to drill. That can be expensive, of course, but newer technologies are also coming forth, so you can like lower your drilling costs and stuff like that, and efficiencies and everything are coming also in. So just be open to that mind that even though it is drilling, and some people do not have a good perception on drilling in terms of oil drilling, if this is like geothermal drilling, there should be no bad things happening over there. This is mainly just for for example, district heating systems and stuff like that. And that can maybe play a big part in terms of lowering electricity demand.
So you want to inspire people?
Yeah,
to
I
do
want
this
to
also?
inspire people. Yeah. You can even be off the grid if you do this. Yeah, if you want to be completely on your own, you can theoretically drill directly into the earth, extract hot water, even have what you call a binary geothermal power plant where you produce your own electricity.
Whoa.
You could theoretically do this, but I mean, it will probably be a lot more expensive over there.
So you're saying all the doomsday preppers, they have a way.
yeah, do a geothermal. Yeah, exactly. Yeah.
Excellent. Well, Kári, thank you so much for joining us today.
Yeah.
That was excellent. Really enjoyed that.
Yeah.
Thank you so much for
Thank you
coming
also just for having me over here. This has been an incredible pleasure to be here, and the lava show itself. Wow, what a place. Yeah.
Thank you.
Thank you. Yeah.
in. Excellent. Thanks, Kári. Well, that was a fantastic interview with Kári. Massive thanks to him for coming in and joining us for that one.
Yeah, it was fantastic. Learned so much.
And we hope you learned a lot too. And if you'd like to get in touch with us for any reason, either, you've got some suggestions or some feedback, we'd love to hear from you. So you can email us at podcast@lavashow.com.
Yeah, and then, of course, you can always follow us on our socials. We're basically on all the typical ones. Instagram, Facebook, TikTok, YouTube, LinkedIn. So, which one do you like?
Yeah. And we'll also, of course, don't forget, we'll have show notes attached where you'll be able to find more info about the guests that we're talking about and the organizations or whatever that they represent. So if you want to find out more information about anything that we're talking about during the show, you'll find that in those show notes. But now, don't forget to subscribe if you haven't already done so, and tell your friends. And we hope to get you back here again for our next episode. Thanks for joining us.
Thank you. Bye-bye.